So let me clean up the graph to show what exactly happens when we have two emitters in the system, and how they can trade off their emissions to have an efficient allocation. So what don't we need anymore? We don't need this graph for the moment. We also don't need this here. We just need the model to visualize here what's going on. So we're gonna have the same kind of graph first of all for firm A, and firm A is gonna have a certain amount of emissions, E0 it's emitting, E0A, and then it's gonna have a marginal abatement cost. And then there's gonna be a firm 2, and how we can actually see, because the government, what it does, it caps the total emissions within the pool, which can be added by those actors. So it caps the emissions which can be added to the common resource pool, and that is done by issuing permits. Permits. The government does this. So the government caps the amount of emissions those two polluters can emit, and we say they are gonna allow 100 units of emissions, or issue equals 100 permits. And now how we can represent then the this in the graph is that we just add another y-axis for the marginal abatement costs of firm 2, MACB, and those are the marginal abatement costs of firm A. And now we have to read the emissions of firm B in this direction and the emissions of firm A in this direction. So to see how much the firm A is emitting, we have some assumed level of emission E0, and then a marginal abatement costs schedule, which is different from the marginal abatement cost schedule of firm A. Because it just is a different kind of industry, and it might face just lower reduction costs of scaling down either its emissions or installing some sort of scrubber, and it's just cheaper for it. So we have the two graphs and the two emission targets, and now the government actually assigns or allocates those emission permits equally among the two firms. So both firms receive 50 permits in the beginning. So they are gonna then, if they have 50 permits, they're gonna face this costs of emissions, which are here on the dotted line. Now both firms have the incentive under this scheme to trade or start trading their emissions, because firm A, as we can see, faces a higher cost of abating its emissions than does firm B at the current state. Like, there's a difference between the costs of abatement for firm A, which are up here, and for the cost of abatement of firm A. And what they want actually to achieve is that both firms face exactly the same cost of reducing their emissions, so that both firms, sorry about this, there's some kind of, here we go, we are back on the picture. Both firms face the same, let me here, same costs of emissions. So they basically, firm A in a market system can buy this amount of emissions until they reach the equilibrium state from firm B, and at a market price of this level P1 they will have the green area of benefits from trading. Now firm B has the yellow area of benefit from trading its emissions and actually scaling its emissions even further down and abating more than firm A, but it will have then this compensation for emitting more, or even more than the compensation, because it actually just faces the costs which are below its graph of reducing its emissions. So without trading, we would actually lose exactly the whole area here. This triangle would get lost as an inefficiency, and economists call this normally the deadweight loss of inefficiency. Deadweight loss. So with a cap and trade system, we have now shown that there's an efficient market outcome of achieving the set emission reductions in the least costly fashion. And if you want to learn how the incentives work, I'm going to show that to you in the next video, how firms actually have even an incentive to lower their marginal abatement costs to have this kind of marginal abatement cost schedule, and to have even greater revenues from reducing their reductions. That's especially the case if emissions are gonna be, or the number of permits are gonna be scaled down over time. But I'm gonna show that to you in the next video, so stay tuned.